Dear students, let us discuss a problem on impact of elastic bodies in this video. This is the problem statement. A ball strikes centrally on another ball of mass twice the mass of the first ball, but moving with a velocity of 1/7 of the velocity of the first ball in the same direction. Show that the first ball comes to rest after the impact. The coefficient of restitution between the balls is 3/4. In the problem, it is given that two balls are traveling in the same direction. If we consider the mass of the first ball as m1, then in the problem it is given that the mass of the second ball is twice the mass of the first ball. Okay. And if we consider the initial velocity, that is the velocity of the first ball before the impact is u1, then in the problem it is given that the initial velocity of the second ball u2 is 1/7 of the initial velocity of the first ball. The coefficient of restitution E is given in the problem as 3/4. It is asked to prove that the first ball comes to rest after the impact. That is, the final velocity of the first ball v1 is 0 after the impact. Okay. To prove that the final velocity of the first ball after the impact is 0, we can use the law of conservation of momentum and the Newton's law of collision. Okay. According to the law of conservation of momentum, the initial momentum of both the balls 1 and 2 before the impact is equal to the final momentum of the balls 1 and 2 after the impact. That is, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay. Here the mass of the second ball m2 is given as 2 m1 and the initial velocity of the second ball u2 is given as 1/7 u1. Okay. In the right hand side, m1 v1 plus m2 is 2 m1 in the given problem into v2. Okay. Here v1 and v2 are the final velocities of the considered balls 1 and 2. That is the velocity of the balls after the impact. We can simplify this equation as m1 u1 plus 2/7 m1 u1 is equal to m1 v1 plus 2 m1 v2. By taking m1 as a common term, u1 plus 2/7 u1 in the right hand side also, by taking m1 outside, v1 plus 2 v2. Okay. Now we can cancel m1 in both the sides. Then we can obtain a simplified expression as v1 plus 2 v2 is equal to this u1 plus 2/7 u1 will be 7 plus 2/7 u1 by taking LCM. So this is 9/7 u1. Okay. So v1 plus 2 v2 is equal to 9/7 u1. We can keep this as equation 1. Next, considering the Newton's law of collision. According to Newton's law of collision, the ratio of the velocity of separation of the bodies and the velocity of approach of the bodies is always a constant. The constant is known to be the coefficient of restitution. So v2 minus v1 divided by u1 minus u2 is E. This is v2 minus v1 divided by u1 minus u2 is given in the problem as 1/7 u1 and the E value is given in the problem as 3/4. Okay. We can simplify this expression as 7 minus 1/7 u1 is equal to 3/4 by taking LCM. This is v2 minus v1 divided by 6/7 u1 is equal to 3/4. This can be written as v2 minus v1 is equal to 3/4 into 6/7 u1. v2 minus v1 is equal to 3/4 into 6/7 is 18 divided by 28 u1. So an expression like this can be obtained. This can be kept as equation 2. We have two equations. Equation 1 is V1 plus 2V2 is equal to 9 by 7 U1. Equation 2 is minus V1 plus V2 is equal to 9 by 14 U1. By adding these two equations, V1 minus V1 is 0, 2V2 plus V2 is 3V2 is equal to 9 by 7 U1 plus 9 by 14 U1. By taking LCM, (27U1 divided by 14). So 3V2 is equal to 27U1 by 14. That gives V2 is 27U1 divided by 14 into 3. V2 is 9 by 14 U1. Now we can substitute the value of V2 as 9 by 14 U1 in equation 1. So equation 1 is V1 plus 2V2 is equal to 9 by 7 U1. Now we can substitute the expression for V2 as 9 by 14 U1 in this equation. This 2 and 14 can be simplified. So V1 plus 9 by 7 U1 is equal to 9 by 7 U1. So V1 is equal to 9 by 7 U1 minus 9 by 7 U1, that is equal to 0. That is, the final velocity of the first ball after the impact is 0, hence proved.